As is always the truth in our study of algebra, finding the square roots of variable expressions follows the exact same patterns as finding the square roots of just expressions with numbers. So, for example, if I take the expression the square root of 36 x to the 8th, we know that that's the same as the square root of 36 times the square root of x to the 8th. Square root of 36 is 6. Square root of x to the 8th is x to the 4th. Sorry for that. I'll make that a little bit clearer. Square root of 6 x to the 4th. Similarly, if I say the square root of 18 a to the 3rd, I know that's the square root of 9 times the square root of 2 times the square root of a squared times the square root of a. Because I'm separating these out because I want to get the exponents to be even and as big as possible. Square root of 9 is 3. Square root of root 2 is root 2. Square root of a squared is a. And the square root of a is a. So this comes out to 3a root 2a. One thing that's a little bit different is if we look at the square root of m squared minus 6m plus 9. Most beginning algebra students think that, oh, I can take the part of this that's a perfect square and the part of this that's a perfect square and let them all in between. But notice up here, everything is multiplied together, and that's why we can take them apart. Before we can take the square root of this, we have to factor it. That gives me m minus 3 squared. And the square root of m minus 3, square root of m minus 3 squared is m minus 3. We actually need to put absolute value symbols around this, and I will explain that to you now. But up till this point, just understand we're doing just what we were doing before with numbers, but now we're extending that to the use of variables. Square roots of variables. If I say square root of x squared, I know that that is x. But just like the square root of, the square root of, let's say, 16 could be either 4 or negative 4. Because of that, when I'm dealing with variables and I'm solving equations, I need to be as exact as possible. And therefore, I'm going to call this the absolute value of x. Because like if I said the square root of 16 is the absolute value of 4, that would take the positive and negative 4 into account. I can't just stick a plus or minus sign in the middle of these because they're going to be longer variable expressions. So let's just say that we've established that the square root of x squared is the absolute value of x. The square root of x to the 3rd. Well, we know we can only take the square roots of positive numbers. Therefore, if I'm taking the square root of x to the 3rd, it must be a positive number. And that means that x itself has to be a positive number. Let's just say, for example, if I were to say I'm taking the square root of negative 2 to the 3rd power, that would mean that I was taking the square root of negative 8, which is not a real number. It is, however, a positive number to say positive 2 to the 3rd. I can take the square root of that. So if this number to the 3rd power ended up positive, then that means it's the cube root we're talking about is positive. That's a long way of saying that I simplify this by thinking of x squared times x, and that gives me x root x, and I do not need absolute value because x to the 3rd must be a positive number, which means that x itself is also a positive number. If I take the square root of x to the 4th, I get x squared, half the exponents. Well, anything squared is positive, so again, I do not need absolute value. For the same reason we knew that x to the third was a positive number and therefore x is positive, works with all of the odd exponents. So this gives me x squared root x, because I guess I should do the in-between step, just so you get more practice. I can think of this as x to the fourth times x, and the square root of x to the fourth is x squared, and root x stays in there. Square root of x to the sixth, well, that is x to the third. Now we get to a situation again where this could have started out, this number is positive, but x to the sixth can be positive whether x is negative or positive. X to the third, that means that x to the third, let's do this over here. Let's say the square root of negative 2 to the sixth power. Well, you may not know this, but 2 to the sixth power is 64. So that's like saying the square root of 64. Okay. And that could be, and we know that's 8, but that 8 could be either is negative 2, sorry, I'm running out of room here. The square root of negative 2 to the sixth power is negative 2, sorry, is negative 2 to the third power, which is negative 8. The square root of 2 to the sixth power is 2 to the third power, which is positive 8. Since we don't know whether this is positive or negative, we need absolute value symbols. From this, the pattern that you can see is that if it starts out even under the radical and it ends up odd outside of the radical, that's when you need to have absolute value. Anything that begins as odd, even if we separate it out over here, if it begins as odd, you never use it. You never need absolute value. If it begins as even and ends as even, we also don't need absolute value because clearly x squared is a positive number. So if exponent is even under the radical and odd outside the radical, you need absolute value symbols. Oops. Okay, so let's just 24 x to the sixth, y to the eighth. Okay, well, we know that 24 is 4 times 6, and that's x to the sixth, y to the eighth. So the square root of 4 is 2. The root 6 stays under here. X to the third comes out, and we do need absolute value because it started out even and ended up odd. Y to the fourth comes out, it started out even and ended up even, so we don't need it. So just so I can say this a little better, 2 times the absolute value of x to the third times y to the fourth times root 6. That's the way you do that. The other thing that's a part of this section is what we call simple radical equations. Oh, actually, that's not what those are. These are just simple equations. They're actually quadratic. So, if I say 9x squared equals 64, way back in 7th grade we learned we are always trying to isolate the variable. Okay, I'm going to write write that on the next line. Isolate the variable. And whatever we do to one side, we do to the other. We're trying to undo. Do to the other. So this is no different. I want to get my x alone. That's x squared equals 64 over 9. To undo x squared, I take the square root of it. And just as we've been talking about, that means this could be positive or negative because it's the square root. And that's x over 3. 8 over 3. So it's important whenever you do this, immediately remember plus or minus.